Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about vehicle to grid system. So let's dive right into it. Now, first thing, what is the problem that we have to go into something convoluted as vehicle to grid system? Well, we want to use renewable energy, not because of environment, simply because they are far more cost effective. At this point in time, even in India and China, solar is far more profitable compared to a coal power plant. So people are building it. Wind farms, same deal. People are building it. But here's the problem. Both of these puppies have more than enough juice to run entirety of humanity, but they are very intermittent. Now, what does that mean? That simply means they can go YOLO on your ass at any moment in time. They can be like, okay, you get a lot of power and poof, done. Good luck. And in case of sun, at least sun does have this one good thing, that if you are in the middle of desert and it's like, it's a good desert, as in like it has not rained for like hundreds of years, you would be in a scenario where it's like it's almost like a clock based system. But then again, you have the issue, what the hell happens at night? So this is one of the serious limitation of renewable energy system. And our grid was designed with very low buffer in its mind. Basically, there is zero buffer. We have a power plant, it produces energy and it must be consumed at that very instant. You cannot have a power plant that is producing bit more or demand that is bit high. No, it has to be perfectly matched. The supply and demand must be matched, and there is like whole control centers in every nation that is like working their ass off to make sure like this remains almost like, of course there is a bit of tolerance there, but that is like almost, it has to be matched. So you cannot have a scenario where it's like a lot of power plant disappears at night. Yeah, this is not gonna happen. Like it will destroy your whole grid. So fundamentally, that creates an issue with frequency and voltage. You could have a scenario where you have too much voltage or too little voltage, and frequency. And like frequency is, that's how, because we have so much spinning mass in our power systems, basically when you're talking about giant steam turbines, that gives us that buffer. And we computers monitor that, like this must be the RPM. Let's say the RPM is 1500, and it's like everything is awesome if it's 1500. The moment RPM starts to go down, that means the frequency is starting to come down. They will open up the steam valve to increase the pressure to maintain the RPM. So there is like a lot of complicated things that is allowing us to maintain that power balance. But what will happen if you are trying to connect something that have no throttle? Basically a solar power plant, as good as it gets. Wind, as good as it gets. Like if you want more out of it, it can't do. If you want less out of it, it still can't do. So that's a very serious limitation. Now, understanding electric vehicles at this point in time is that electric vehicles are taking over the market, and electric vehicles are just a simple car where instead of a basically engine, it has a basically motor, which is even simpler, much smaller, much higher power density. And instead of fuel tank, it has huge ass battery banks. Now it does work. Now to give you a context of that, like in most Indians are used to having battery banks in our house. We call them inverters. And even my inverter backup is like 24 volt system, 200 amp hour batteries. That is around 5 kilowatt hour capacity. Now the cheapest electric car that I could find in India that still has more than 10 kilowatt hour of capacity, and you're talking a mid-range electric car that has around 30 kilowatt hour of electrical capacity. And when you're going high end, you can easily achieve 100 kilowatt hour of capacity. And I'm talking four-wheelers. The moment you talk about bus and trucks, yeah, good luck with that. So we have boatload of energy in these things. Basically, some people have called electric vehicles as like battery on wheels, and they are not tangibly wrong. So fundamentally, it is a big source of energy. However, one thing you have to understand, personal electric vehicles, I'm not talking about fleet vehicles, basically vehicles that are being used by like taxi services. Personal vehicles are generally static most of the time. What does that mean? That simply means you woke up in the morning, you freshen up yourself, you took your car, you went to office, that's it. Now that car is still sitting in the parking garage for let's say 8 hours. Then you come back at night, and then you plug it in your basically garage, and then it stays there for 12 or 13 hours. So reality is, car has like a use time, on time is very little. Like how many time you are actually utilizing, that's very little. Now that creates a window. There is a window of opportunity where you have the energy capacity of the giant ass battery, and you have time also. So even if you discharge this, you still have enough time to recharge it also. So there is a probability of alternate use. Basically, this is a vehicle, you already invested into it, but if you can get some extra use out of it, that would be awesome. So what's the idea behind this? Like how the heck you want to actually do this? Well, one good thing is that most electric vehicle system have very good inverter system built into them. Now inverter systems generally takes DC and makes them into AC. Most cars nowadays generally have a system that can take DC and make them into 3-phase AC, and with very good frequency control. This is a very critical aspect. You cannot just send YOLO electricity on that, and frequency has to be phase matched also, otherwise it will simply go boom. So we have developed this technology specifically for solar industry, and electric cars just have a much higher variant of that. So that's not an issue. It's like, can you technically do it? Well, that's only a firmware limitation. And of course you still want to have like, bridge diodes that are like allow you energy to flow backwards, but like it can be done. Most inverters do have that, and you do understand it's like most of the time the inverter is acting as a charger. So we do have most of the system in place, and surprisingly large amount of vehicle can activate this sort of function if they have like certain protocols in place. So it's not a electronic issue, it's not a hardware issue. It's just like if there is a standard for vehicle to grid system, it's like it will be barely a software update for most cars, newer cars, not the older ones, not very old ones, but newer cars. Anything that is made after, let's say, 2010 or 2015 should be easy peasy. And there is another aspect, like at the end of the day you will only do this if it makes you richer. Now how can you be richer? Well, there is a power difference at power rates. What does that mean? That simply means if you are extracting 10 kilowatt of energy to charge your EV at night, you would be paying, let's say, 5 rupees. But what will happen if you do the same thing, same 10 kilowatt hour you want to charge from a grid, you will be end up paying, let's say, 10. Your price would be half from night to day. So what does that mean? That simply means if you can charge at night time, basically when the prices are low, and you dump them at the peak hour, you can make money. So that's the whole point of it. And bidirectional energy meter, which is a very complicated system, it has already been developed. Most of the Indian homes already have a bidirectional energy meters nowadays, because like again solar is started to took off, so people started developing technology for it. And because of that, that technology is already taken care of. Like think of it this way, like bidirectional energy sounds so weird. It's like even if people are investing in generators, the first thing they do, install a huge ass breaker in our home that has contactor, and the moment power goes out and you want to start the generator will not trigger on until that contactor is on, as in disconnected with the grid. You never want to send electricity in the grid, but how the heck we are gonna send electricity in the grid? Well, there is a proper way of doing it. It just has to detect the grid is sending it first. It has to detect that. If it detects that grid is down, it will not send energy. That's the purpose of like, of course there is a lot of subsystems into this. So this bidirectional energy transfer is something that has been sorted. Like we got this, we have already solved this issue. So utilizing the core principles that have been developed with solar system, you can have that system. And cars have so much capacity. Like people, hey, I have range anxiety, so I buy a car that has like 300-kilometer range or 400-kilometer range, but how much do you drive? 40. So in those sort of scenarios, you have lot of capacity, like lot of capacity and lot of time that you can utilize that puppy for, and it will make you money. So that's why people will do it. It's like, yeah, it will make you money. If you're like, hey, it makes me, let's say, even as little as, let's say, cost of your tire. Let's just say how much money you spend on your tire, and every month it makes you enough money to, replace a tire in case of a wore down, damage, puncture and all that jazz. You will still do it because it's like a profitable. So that's the idea. So are there any problems in this? Well, absolutely. It will take certain life away from your battery, but there is a good side to it. Think of it this way. If you are a human and battery like this, you can be living to 90, but you will be in stretcher at the later half of your life, or you can only live till 80, but you will be healthy till 80. So that's the benefit of doing the vehicle to grid system, because most of the time batteries are overcharged. So you do not want your battery to be at like, as high as like 95% charge or 100% charge. You don't want that. Like for long journey, awesome. Like, if you charge it, please try to discharge it as quickly as possible. But when you're talking about it's in my garage and it's charged to 100%, that's degrading in battery. But if it's connected to the grid will do deep cycle on it, and that is very good for its overall vitality. Basically it's gonna perform better. The lifespan is gonna shrink, there is no denying that, but its vitality will be better. So you will have like, hey, if I press the accelerator, my car goes poof. That will still happen after 10 years. So that's why that's still a compromise, because many times people may not understand that. They're like, I don't want to, and again, it's your choice. So that is something that people have to swallow. That pill has to be swallowed. Then a good smart meter and safety system, because that's the whole thing. A bidirectional energy meters disconnects the moment it finds hey, wait a minute, there is no power in the grid, I'm gonna disconnect. That's a very critical system, and if you have a failure, you could literally injure or even end someone's life. So that is a very serious thing. That smart meter and safety systems that have been developed for solar must have to be reinforced so everybody can do it. Right now, solar system, yeah, it's a system. Yes, it's a reliable system, but it's like, they are assuming it's going to be used like, one apartment in each block. They're not expecting every person who has a car to utilize the system. So system needs to be much more robust. And when you're talking about electric vehicle, it must need an AI, because yeah, if you start to do manually, yes, it would be very awesome to do it like, first few days. Yeah, can you, what do you want to make $5, do you want to make $10, do you want to $20, like that would be awesome. But you will forget someday, and you will make a mistake, and you will end up with a dead EV. Basically, you want to like, hey, I'm gonna go to buy grocery, and my EV is like, you can't, I'm discharged. So that's an issue. So you need an AI that can do basic pattern recognition, where it's like, for example, from Monday to Thursday, you have a fixed routine. It knows for a fact that it has studied you for almost a month, where it's like, dude, your car battery has range of, let's say, 150 kilometer. You barely drive 30 kilometer. So accounting for some buffer, some issues and all that, just it will give you energy of 50 kilometers. But that 100 is like, yeah, that is open to market, and then the AI is gonna do the buying and purchasing. Basically, it's like, hey, I charged myself at night, I'm gonna sell it at during when I'm parked at the office, and sell electricity at peak time, so I'm gonna make some profit. And it knows for a fact that you never do that, and on Friday it will disconnect it, because it knows, hey, Friday night you want to do something fancy, and it's like, you want that 150-kilometer range, is going to do that. It's like, you need something that advanced. You don't need mobile app. Sounds good, but it's like, it's a starting thing. If people will make mistake, and that will, like, literally, once you make that mistake, you'll be like, I'm never gonna do this. So we need a good AI for that. And infrastructure update also is required, because once you start to build this, you are inherently adding a sort of quote of peak power plant to your system. So you have to redesign the basically power plants that are already working to account for it. Because you have to understand, supply and demand must remain in balance, so you must account for it. If you're like, to this municipality have like this many cars added to it, so you have to calculate for that. It's like, this many energy, this much energy we have, this is the lowest we have, this is the highest we have. You have to account for that. So that does require a bit of update. It can be done, it's not too much issue. And money has to be well balanced, because you may be like, hey, I want to make a lot of money. Here's the deal: inherently that only can be done if electricity is too expensive, and you don't want very expensive electricity, so it has to be balanced. So there are some problems. It's not a super easy thing. There are some issues that has to be worked out. So what can we expect in future? Well, reality is we need a lot of energy storage. Like, energy storage is like holy grail at this moment in time, because I've specified solar already makes more sense than coal. Then why the heck everybody is not doing it? Simple, we don't have energy storage. The moment we have energy storage that can even allow us as little as, like, cross over a day. It's just like, this power plant produces 20 kilowatt, let's say 20 megawatt, and only sells, let's say, to this grid 5 kilowatt, but it has, like, stores that 15 for time when it's not on. Awesome, everybody will start to do that, every household will start doing that. But right now we do not have any technology that is cheap enough, efficient enough, long-term enough, where we can do that. Now, EV market is growing, that's a reality, and it's not growing because people care about environment. They are growing simply because petrol prices are going ludicrous. Heck, petrol prices crossed 100 rupees in India recently. So like till 90, people are like, we can push it, manage it. Like, the moment it crossed 100, it's like, nope, I'm buying an electric car. So that market is growing, and it's just a huge ass battery on wheels. So a lot of people are working on it. It's like, from Nissan to Tesla to every company that has a big enough market share, they are working on it. It's not something that, okay, some fringe people are working on. Like, more than enough people are working on it. And a lot of new rules and regulations are also being placed, because again, the moment you are talking about something as serious as electric utility, you need some serious guidance, where somebody does not end up getting exploited or end up destroying a whole grid because oops. So you want to make sure there are some good rules that are being worked on, and thankfully some people are already working on that rule department, and it would be one of the tools that we'll utilize in the future. I do not see, many times people talk about technologies as in, like, this technology is going to solve all our issue. That's never going to happen. Now, of course, this will be one helpful tool. Like, same way solar is a tool, wind is a tool, this will also become a tool that we'll utilize to improve our situation. So I do see this becoming a useful thing, if all the legal issues, all the marketing, and all the, like, balancing and all that, because it does require a very steep learning curve to solve these issues. But let's say we solve this, I can easily see this thing becoming an important part of our life in the future, and we will not even know it. It's like, it will happen in the background. So this was my presentation on vehicle to grid system. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.